Okay. Now, what we told about, that is the waiting time is the crucial performance parameter that we use to evaluate the performance of a scheduling algorithm. Okay, so what are the different types of scheduling algorithms are available? Okay, so there are, so this is module 2 lecture 5. This is the last lecture of this process part. Okay, so the first is the scheduling algorithms and what are the different types of scheduling algorithms that are available. The first one is the first come, first serve scheduling. First come, first serve scheduling means the process that arrives at the this is one ready queue first or in the RAM first or in the memory first is allocated the CPU first. So it will not take into consideration whatever its processing time is, what are the CPU burst is. It will not take into consideration that. It is the process which will come first. It will get the first priority and it will take over the CPU. Okay. Since we will see what is the problem with this method, first come first serve scheduling, and why, then the next algorithm, that is the shortest job first scheduling, is better than this one. Then again, certain processes require more, what you can say, that is, there are certain processes require to preempt a job in the scheduling if the job is running indefinitely. And that is why this process also comes into place, this algorithm also comes into place, that is preemptive shortest job first scheduling. Then certain process has priority over other processes. So that is, for in that case, we learn the algorithm that is priority scheduling. Another process, that is the round robin scheduling. Round robin scheduling is, so it is nothing but what we do, we allocate a time slice to each process. Okay, so each and every one will learn. Another is the multi-level queue scheduling. Okay, so the processes are divided into queue stacks and they run as per their way. So multi-level feedback queue scheduling is what? So we will learn about that. That basically, if the priorities are different, so basically their waiting period becomes higher. So in that case, we can move processes from each queues. Okay. So do not get confused. Do not get do not basically think about different things. What sir is saying. Just we will look into them one by one, and you will understand them. Okay, this class is going to take a long time, so keep the water in hand and everything in hand. Okay, and we are going to solve certain numericals. Okay, now the first is the first come first serve scheduling. With this scheme, the process that requests the CPU first is allocated the CPU first. Okay, now let us think that there is the RAM is there. Okay, our memory is there. One second. So So this is the RAM, and it can only, what you can say, accommodate three processes. So the first one is P1. The second one is P2, and the third one is P3. Okay. Now the thing is, now let us understand that there are certain things to be understood. Okay. Now each and every process has a certain CPU burst time left. That is, P1 has burst time of 24 milliseconds, P2 has a burst time of 3 milliseconds, and P3 has a burst time of 3 milliseconds. Means that is the only time that they will occupy the CPU. Okay. So this is the CPU. Okay. Okay. So this is the CPU, And in the first case, if we see that there are P1, P2, and P3 processes, and they take certain time. So P1 has a CPU burst time of 24 milliseconds. P2 has a burst time of 3 milliseconds, and P3 has a burst time of 3 milliseconds. So the waiting period for P1 is basically, if it comes basically first, right? Let us understand how much. So P1 comes first, and it takes around 24 milliseconds to complete its job. Okay. So P1's waiting time is basically 0. Because it is the first job, it is allocated to the CPU. But the next job that comes in the CPU is P2. And after that is P1 completes, then only P2 can complete. So P2 has to wait for P1 to complete its cycle. So P2 has to wait for how much time? It has to wait for 24 milliseconds. So P1's waiting time for CPU is 0, but P2's it is 24. So now P3 comes next, and P3 has a burst time of 3 milliseconds, and it has to wait for P1 and P2 to complete, because these are the first two processes. So P1 is the first, P2 is the second. After P1 and P2 completes, so then only P3 is allocated. So the waiting time of P3 is how much? 24 plus 3. It will wait for 27 milliseconds, then only the P3 will be allocated to the CPU. Understood? এটা বুঝতে পেরেছো?
হ্যাঁ স্যার।
Okay. So what will be the average waiting time in this case? In the first case, this is the first scheduling. So for the P1, the average waiting time is 0, because this is the first process. It comes and it takes the CPU. So the average waiting for P1 is 0. Okay. But for P2, it is 24 milliseconds. It has to wait for P1 to complete. So it is 24 milliseconds. For P3, it is 27 milliseconds. So if we add them up and we divide by 3, since there are 3 processes only, we get the average waiting time for each process. So in this case, the average waiting time is around 17 milliseconds. Understood? এটা বুঝতে পেরেছো?
হ্যাঁ স্যার।
Okay then. Now let us see if it can be reduced. Supposedly P1 and P2 and P3 are the 3 processes, but we will allow P2 and P3 to complete it first before P1. So let us say P2 comes first, then P3, then P1. Then in this case, P2's waiting period is 0, P3's waiting period is 3 milliseconds, and P1's waiting period is how much? 6 milliseconds. So in this case, P2 comes, so it is allocated first, so its waiting period is 0, 0. Right. P3, it is 3 milliseconds plus 3, and P1 is 6 milliseconds. 3 plus 3, that is 6. So divided by 3 is 3 milliseconds. So we see, if we just alter the positions of the processes in this one, that is the first in the basically ready queue, the average waiting time comes down significantly. In the first case, it was 17 milliseconds. In the second case, we just altered the sequence of the processes, and it became just 1/5 of the entire time. Understood this one?
Yes, sir.
Okay. So another problem of the first come first scheduling is basically the convoy effect. What is a convoy effect? So let us understand that there is a CPU is there, right? And all the processes, let us say there are 10 processes are there. Now, in the 10 processes, one process is CPU bound. Means it has, let us say, each process is allocated 100 milliseconds time. So, one process is CPU bound means 90% of it is allocated to the CPU, 90%, and 10% will be allocated to other IO processes. Okay. And other 9 processes are, let us say, 90% is allocated to the IO and 10% is allocated to the CPU. Okay. So in the first come first serve scheduling, what happens? Supposedly that first process comes, that is 90 milliseconds. It takes the CPU for 90 seconds. Other 9 processes has to wait, right? But after 90 milliseconds, the P1, that takes maximum time, it leaves the system and goes to the IO. And all other processes just come and they do their job in another, let us say, 90 milliseconds. But in between, since P1 is CPU bound, it takes lesser time than other processes, so it immediately joins the queue. All the other processes which are IO bound, they complete their CPU time and they come into the IO and they take maximum time there. But CPU time again it takes maximum time in the CPU. But on all the IO processes has to wait, right? So basically, this is the thing that has happening in the operating system. So this kind of effect is called the conveyor effect. বুঝতে পারলে? Hello, hello, hello. Are you there?
Yes, sir.
বুঝতে পারলে কি বুঝতে পারলে? কনভয়ের এফেক্ট মানে কি? একজন আছে, মানে একটা বড় ট্রাক দাঁড়িয়ে আছে, সবকটা ছোট ছোট গাড়ি দাঁড়িয়ে আছে, ঠিক আছে? তারপর এই বড় ট্রাকটা আবার ধীরে 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 আবার একটা জায়গাতে এলো, আবার সবকটার পিছনে দাঁড়িয়ে পড়লো, ঠিক আছে? এটা তোমরা কিন্তু একটা বাসে সব থেকে বেশি দেখতে পারবে, ঠিক আছে? তোমরা যখন একটা ছোট রাস্তার ছোট গলির ভিতরে যাও, ঠিক আছে, তখন কি হয়, একটা বড় বাস দাঁড়িয়ে থাকে, তার পিছনে তোমরা সবাই দাঁড়িয়ে থাকো, তোমরা বাঁ দিকে যেতে পারো না ডান দিকে যেতে পারো, ঠিক আছে? কারণ তোমাদের ছোট ছোট বাইক আছে, সাইকেল আছে, তোমরা বাসটাকে ক্রসই করতে পারছো না, কিন্তু বাসটা পুরো রাস্তাটাকে কভার করে রেখেছে, ঠিক আছে? কিন্তু তারপরে এই ব্যাপারটা কিন্তু কন্টিনিউয়াস হতে থাকে, মানে পুরো রাস্তাটাই বাসটা তোমাদেরকে আটকে রেখে পুরো রাস্তাটা জ্যাম করে চলতে থাকে, আর তোমরাও পিছন পিছন চলতে থাকো। কিন্তু তোমাদের ছেড়ে দিলে তোমাদের তো লাভ, তাই না? ইউ ক্যান ইজিলি, মানে বাসটা যদি একটু সাইড হয়ে যেত, তাহলে তোমরা কিন্তু পুরো রাস্তাটা পেরিয়ে রাস্তা ক্রস করে দিতে, তাহলে তোমাদের কিন্তু আনন্দ হতো, ঠিক আছে? কিন্তু ওই একটা ছোট বাসের জন্য একটা রাস্তার ভেতরে একটা জ্যাম তৈরি হয়ে যায়, ঠিক আছে? সেম থিং অ্যাবাউট দ্য প্রসেস। একটা সিপিইউ বাউন্ড প্রসেস ইজ এ হেভি প্রসেস। ও যদি সিপিইউটা সবসময় অকুপাই করে রাখে, বাকি সবকটা প্রসেস কি করে? ওয়েট করতে থাকে কখন ওটা কমপ্লিট হবে, তারপর আমরা আমার কাজটা করব, কখন আমরা বেরোতে পারবো, তাই না? Understood this one, conveyor effect?
Yes, sir.
So that is one of the disadvantage of this first come first serve schedule. Okay. So what is the way out? So you allow the smaller processes. Smaller processes means the processors are not small, their CPU time is smaller. So you allow the smaller processes to do their job first, then allow the bigger processes. So in this case, we come across this scheduling algorithm, that is the shortest job first algorithm. So when the CPU is available, it is assigned to the process that has the smallest next CPU burst. So there are 4 processes, P1, P2, P3, and P4, and their burst times are 6, 8, 7, 3. Right? So what is the smallest burst time among them? You tell me. You tell me. সব থেকে ছোট প্রসেস কোনটা?
P4.
P4 এর 3, তারপরে P1, তারপরে P3, তারপরে P2।
P2.
হ্যাঁ, তার মানে প্রথমে কে যাবে? P4 যাবে, ঠিক আছে? P4 এর পরে কে যাবে? P1 যাবে। P1 এর পরে কে যাবে? P3 যাবে।
P2
তারপরে P2 যাবে, তাই তো? তাহলে P4 এর ওয়েটিং টাইম হচ্ছে কত? 0 মিলি সেকেন্ড। দেখো 0 মিলি সেকেন্ড P4, P1, P2, P3, P4। তারপর আমি যাব কোনটা? P4 এর পরে যাবে P1। P1 এ কত ওয়েট করতে হচ্ছে? 3 মিলি সেকেন্ড ওয়েট করতে হচ্ছে P4 এর কমপ্লিশন পর্যন্ত। তো P1's ওয়েটিং টাইম ইজ 3 মিলি সেকেন্ড। তো এখানে P1 এর হচ্ছে 3 মিলি সেকেন্ড। সো নাও তারপরে কে যাচ্ছে? P3 যাচ্ছে। P3 কার কমপ্লিট করবে? P4 আর P1, that is 3 plus 6, 9 milliseconds. So P3's waiting time is 9 milliseconds. Finally, after all these jobs complete, then only P2 comes into picture, that is 3 plus 7, 10, 10 plus 6 is 16 milliseconds. So in that case, what happens? 3 plus 16 plus 9 plus 0 divided by 4 is equal to 7 milliseconds. Okay, that is the average waiting time in the shortest job first schedule. বুঝতে পারলা?
Yes, sir.
This you understood? ঠিক আছে? Every one of you understood? Every one of you understood? এই ছেলেরা বলো, বুঝতে পারলে? প্রীতম, রাহুল, সমজিৎ, দীপ্তিমান। এই দীপ্তিমান, বুঝতে পেরেছো? এই প্রীতম, তোমার কিন্তু হ্যান্ডরাইটিং খুব খারাপ, তোমার হ্যান্ডরাইটিংটা ঠিক করতে হবে। আমি তোমাদের আজকে চেক করছিলাম অ্যাসাইনমেন্টগুলো খুব ভালো করে লেখনি তোমরা। ওকে, Now, it is not always possible to learn what is the job that is the means which job is the basically we cannot predict which future job will have the shortest time first. So another way it can happen is this can happen that all the jobs do not come at a time, right? They wait for certain time and then only it comes, right? Means one process arrives at time 0. Another process comes at time certain 10 after 1 millisecond. Another job comes after 2 milliseconds. Another job comes after 3 milliseconds. That's way the processes come to the scheduling algorithm, right? So preemptive SGF algorithm will preempt the currently executing job, whereas the non-preemptive SGF algorithm will allow the currently running process to finish its CPU first. Now the thing is that if it happens, the arrival time of all the processes are different and their burst times are also different. But the algorithm running is basically shortest job first scheduling, right? So supposedly a job that was earlier in the system, it takes around 10 milliseconds to complete, right? And it has completed around 1 millisecond of its job. So it is important that another job that comes after that process, which has a smaller with smaller execution time, let us say 1 millisecond. So what it will do, what the scheduler will do, the scheduler in order to reduce the average waiting time, it will remove the first process from the CPU and will allocate the CPU to the second process which has a smaller execution time. Understood this one?
Yes, sir.
Now let me define it again. Okay, supposedly, uh, supposedly, let us everyone has gone for a let us say some appointment with the dentist, right? Now let us say a dentist job. Basically, he sees that there are three patients. Two patients are there whose problem is much higher, right? And they will take much more time. So he calls them first, but then only a third patient arrives who says just he needs certain medication. So what he will say, okay, we will wait. Tell the patient, just you wait outside. I'll check this patient, right? I'll check this patient. He has just I have to give him some pain medication. He will give the pain medication, and then you again come back. Then that the second patient comes around. He comes into the doctor's chambers, and he takes all the medications he requires. Then he sends the first patient out. Then he pulls the first patient who has a lot of job to be done. This one you understood? এই তোমরা বুঝতে পারলে?
Yes, sir.
স্যার
এই
আরেকবার।
ছেলেরা কিছু বলছে না, রাহুল টাহুল কিছু বলছে না।
স্যার আরেকবার একটুখানি বলুন।
আচ্ছা ঠিক আছে, ধরো একটা ডাক্তারের কাছে পেশেন্ট আসছে, ঠিক আছে? একটা পেশেন্ট প্রথম থেকে এসে বসে আছে, ওর ওর অনেকদিন ধরে দাঁতটা একটু ইয়ে করাবে, ক্লিন করাতে ওর মোটামুটি আধ ঘন্টা টাইম লাগবে, ঠিক আছে, ডেন্টিস্টের কাছে, ঠিক আছে? তো ডাক্তার ওকে প্রথমে ঢুকিয়ে নিল, তারপরে যখনই ঢোকালো তখনই ডাক্তার দেখলো আরেকটা পেশেন্ট এসছে যার শুধু একটা পেন মেডিকেশন দিলেই হবে, মানে ওকে 1 সেকেন্ডের মধ্যে 2 সেকেন্ডের মধ্যে ছেড়ে দেবে। তখন ওর প্রথম পেশেন্টটাকে বললো ওর যতটা কাজ হয়েছে হয়েছে, বললো তুমি একটু দাঁড়াও বাবা, আমি সেকেন্ড পেশেন্টটাকে দেখে নিই, একে এখনই ছেড়ে দেবো, ওর কাজ আছে। দিয়ে ওর সেকেন্ড পেশেন্টটাকে ঢোকালো, ঠিক আছে, ফার্স্ট পেশেন্টটাকে দেখা ছেড়ে দিল, বলে একটু পরে ওকে ওকে 1 মিনিটের মধ্যে পুরো কাজটা সেরে দিল। দিয়ে ওকে প্রথমে পাঠিয়ে দিল সেকেন্ড পেশেন্টটাকে, দিয়ে আবার ফার্স্ট পেশেন্টটাকে উপরে কাজ শুরু করলো। এবার বুঝতে পেরেছো?
হ্যাঁ স্যার।
ঠিক আছে। So like this one, if you see this one, this processes, this operating system processes, let us say there are processes P1, there are processes P2, there are processes P3, and there are processes that is what you can call as P4. Now let us say process P1 comes at arrival 0. So this process has first priority over the CPU because at that time no other processes were there. Okay, but its burst time is 8 milliseconds. So after 1 second, 1 millisecond, P2 also arrives, right? But P2's arrival time is at 1 millisecond, but its burst time is 4 milliseconds. The process that was running in the CPU had 7 milliseconds left. So P2, since it has a lesser time, lesser execution time, it will get priority over P1 and it will remove P1 from the CPU. Okay. P2 now the scheduler মানে ডাক্তারটা এবার কি করলো, P1 কে সরিয়ে দিল, পেশেন্ট 1 কে সরিয়ে দিল, পেশেন্ট 2 কে ঢুকিয়ে দিল। ঠিক আছে, এর অ্যারাইভাল টাইম একটু পরে হলেও এর ওয়েটিং টাইম একটু কম, মানে এক্সিকিউশন টাইম একটু কম। ঠিক আছে, P1 কে সরিয়ে দিল, তারপর P2 কে ঢোকালো। Now after it is removed P2, let us say after that P3 P4 comes, but P3's waiting time is basically execution time is more than P2. P4's execution time is also more than P2. So in this case, they cannot preempt P2 process. So P2 will run, since it has the least amount of time, execution time, it will run the entire cycle. Okay, so P2 will take the entire cycle. So after that, P2 removes, only after P2 gets out, only after P1, P3, and P4 will compete for CPU, right? So P1 has 7 milliseconds left. P3 means P2 now has complete after 4 milliseconds. So P3 has how many milliseconds left? 9 milliseconds left, and P4 has 5 milliseconds left. So between P1, P3, and P4, P4 has 5 milliseconds left. So P4 gets more priority over P3 and P1. After P4 completes, P1 has 7 milliseconds left, P1 will take the place. And after P1 completes its job, then only P3 will get the CPU. Understood?
Yes, sir.
Okay, so now let us look into the maths. So P1 first comes, it comes P1 0, right? After arrival time 1, P1 has 7 milliseconds left. So P1, P2 gets over. So P2 now takes over the CPU and P2 executes. So it will execute for the full cycle because it has the least amount of time. So P1 will execute, P2 will execute for 1 plus 4, till 5 milliseconds it will, the P2 will complete. But now P1, P3 and P4 are left. Well, 1 second, I'll just write a mail and come back to you.
Okay, sir.
Okay, sorry about that interruption. Okay, hello. Now, can you
Yes,
all
sir.
hear me?
Yes, sir.
Okay. Now let us look into this algorithm. So let us say P1 was allocated 0. So at P1 0 came, P1 was the only process at the 0th time. So P1 came, it occupied for 1 milliseconds, then P2 arrived. So it has a burst time of 4 milliseconds. So it preempted P1. So it took the all time because P3 and P4 has a higher execution time than this one. Then after P2 gets removed, P1, P3 and P4 are left. So P4 executes for again 5 milliseconds. So after P4 leaves, so P1 and P3, P1 executes for 7 milliseconds and then only P3 gets its job. Right. Now let us compute the average waiting time. So for P1, let us say the waiting time. So at first it comes, right, 0. But then it leaves the system after 1 millisecond. Right. So P1 was there. Then after it came after 10 milliseconds. So at this time, so see, P1 waits for around 10 minus 1, 9 milliseconds. Right? So P1 that was there, it earlier it was there, then it wait for 10 milliseconds to complete. So it is around average waiting time will be 10 minus 1, 9 milliseconds. Okay, now P2. P2 came after 1 milliseconds, right? And then it completes its job. So its waiting time was 1 minus arrival time. So 1 minus 1 arrival time is again 0. So P2 is 0, right? Then P3. Sorry, P3 came after 17 milliseconds. Okay, and it completed its jobs and it left. So its waiting time in the circle is 17 minus 2 milliseconds. That is the arrival time. Means it came after 2 seconds. So its arrival time will be sorry, its total waiting time is in the queue will be 17 minus 2, that is 15 milliseconds. And lastly, it is called P4. So P4 is came after basically after so P1 and P2 completes. So P4 waiting time was 5 milliseconds plus minus arrival time, that is 3 milliseconds. So 5 minus 3 milliseconds. So total waiting time is 9 plus 0 plus 15. 9 plus 15 is 24. 24 plus 2 is 26. 26 divided by 4 is 6.5 milliseconds. Understood the maths?
Once again, sir.
আচ্ছা P1
আরেকবার
প্রথমে
আপনি
আসলো,
কি
P1's arrival time is 0. It was the first process in the ready queue.
Yes.
Okay. So its arrival time, so it's first it was 0. It worked for 1 millisecond, right? After that P2 came and it preempted P1, মানে ফার্স্ট পেশেন্টটাকে উঠিয়ে দিল, যা তুই বেরো এবার, আমি আমি আমার কাজটা 4 সেকেন্ডের মধ্যে কমপ্লিট করব। So P1 was removed, right? And then P2 came, right? P2 came after 1 millisecond. So P2's came after 1 millisecond, so its waiting time was 1. But since its arrival time was also calculated, so after 1 millisecond, so it is P2 is 1 minus 1, that is 0. ঠিক আছে, so P2's waiting time is actually 0 millisecond. ঠিক আছে, এবার তারপরে কি আসলো, বেসিক্যালি after 5 milliseconds all the processes are there, right? P1, P3 and P4 all are there. P1 has 7 milliseconds of work left, P3 has 9 milliseconds of work left, and P4 has 5 milliseconds of work left. So P4 has the smallest burst time among P4, P3 and P1. P2 has completed its job, so P4 is allocated the CPU. So P4 comes and it takes the CPU after P2, right? So from 5 to 10 milliseconds, it takes the CPU over, right? So P4's waiting time is how much? It waited for 5 milliseconds. It took the CPU after 5 milliseconds, but it arrived later. It arrived later, but basically after 3 milliseconds. So P4's waiting time in the CPU is will be 5 minus 3, 2 milliseconds. ঠিক আছে,
Yes,
এটা
sir.
বুঝতে পেরেছো? Hello.
Yes, sir.
Okay. Now what are the jobs that has completed? P2 has completed and then P4 has completed. The jobs left are P1 7 milliseconds and P3 9 milliseconds. P1 has 7 milliseconds left, right? So after P2 and P4 completes, P1 again comes into picture. P1 was earlier there in the system. P1 was earlier there in the system. But after P2 and P4, its turn came after 10 milliseconds. So, but after how much time it came? Means it was there earlier, then it was preempted. So it has 1 millisecond of work at least means completed. So it has to wait 10 minus 1 millisecond. Although this is not the arrival time, this was we can call as the preemption time. So it has to wait for 10 minus 1, 9 milliseconds.
Okay, sir.
ঠিক আছে? Understood? Now P1
Yes,
has
sir.
also completed, P2 completed, P4 completed, P2, sorry, now the time left is P3. So P3 comes after all this processes is completed, that is after 17 milliseconds it comes into place and then it completes the job. But it has come after 17 milliseconds, but its arrival time was after 2 milliseconds. So 17 minus 2, that is equals to wait for 15 milliseconds in the queue. ঠিক আছে?
Yes, sir.
হ্যালো, বুঝতে পারলে?
Yes, sir.
Okay, so total divided by 4 is around the total PMT shortest jobs for scheduling is 6.5 milliseconds. বুঝতে পারলে? একটা
Yes,
অঙ্ক
sir.
দিই এবার।
Feel, sir.
যারা প্রায়োরিটি দেখি তো অঙ্কটা আছে কিনা। তো প্রায়োরিটি একটা প্রায়োরিটিটা করিয়ে দিই তারপরে অঙ্কটা দিই। Okay, now let us look at the priority scheduling. Priority মানে কি? যার highest priority সে আগে CPU কে ধরে নেবে। ঠিক আছে? That is the whole principle of priority. So let us say P2, so let us say 1 is the highest priority and 5 is the least priority. So let us say CPU is allocated to the process with the highest priority. A major problem with this priority scheduling is indefinitely blocking or starvation. মানে low priority processor কোনোদিনই CPU পায় না। So P1, P2, P3, P4, P5. So burst time is 10, 1, 2, 1, 5. So we do not consider the shortest job first or all first come, first serve. We consider the priority in here. So priority is the main. So who gets the job first? Who gets the CPU first? P2. Its priority is highest. So it gets 1. After that, whose priority is higher? 2. That is P5. P5 then completes this job. Then after that, whose priority is higher? 3. P1. After that, P1 completes this job. Then after that, whose priority is higher? P3. Its job priority is 4. So P3 gets the job. So they got the CPU. And lastly, whose priority is the least? P4. So P5. Lastly, P4 gets the CPU again. Okay. So in this case, it is very easy to compute. So let us say for P1 it was least priority. P1 is 6 milliseconds plus 0. That is for P2 is 0, highest priority. 6 plus 0. P3 is 16 milliseconds. P3 is 16 milliseconds. P4 is 18 milliseconds. 18 milliseconds. And P5 is 1 millisecond. So P5 is 1 millisecond. So the total waiting time is 8.25 milliseconds. ঠিক আছে, বুঝতে পারলে?
Yes, sir.
আচ্ছা, তোমাদের এবার একটা প্রবলেম দিই। কপি পেস্ট করা যায় এটাকে? না, করা যাবে না। Okay. প্রবলেমটা এক্স না, প্রবলেমটা নিয়ে নাও, সলভ করো। ওকে, এই তোমাদের রোল নম্বরটা লিখে দাও তো। সবাই রোল নম্বরটা লেখো নিজের। 1 2 3 4 5। 1 2, আরেকজন আছে, একজন আছে। 1 2 3 4 5। 1 2 3 4 5 6। ওকে, ঠিক আছে। উই উইল টক অ্যারাউন্ড 12:05। ওকে, 12টা 5 আবার কথা বলবো আমরা।
Okay, sir.
ওকে, so
Okay,
you
sir.
can leave. You can leave the meeting.
Thank you, sir.
We'll talk around 12:05, 12টা 5 এর সময়।